In chapter 4, we will talk about dynamics when the object starts to move. If we have an object and we have a force acting on the object, so the object will start to move. If we have two forces on the same object, we add these up. If we have friction or air resistance, so the total force acting on the object, it's F1 plus F2, which are acting to the forward, minus friction, which is acting on the opposite direction. Okay, this is the resultant or total force acting on the object. Newton have three main rules or laws. The first law, talking about the object if it is stays stationary. Newton said that stationary object stays stationary. If we have object in a place and it is stationary, it stays stationary. And if the object moving by constant speed and same direction, the object stays moving, okay, unless a resultant external force acting on the object changing its direction or change its speed or both. So the first law of motion restate Galileo about the nature of the motion. Everybody continues in its state of rest or uniform motion unless acted on by a resultant external force. This is Newton's first law. Newton's first law is called the inertia law. What is the inertia? Inertia, it is the resist of the object to change its motion. Okay, if we have a car and the car moves by a constant speed and you press on the brake, the car will not stop spontaneously. It will move some distance forward, okay, because it still have energy. This is inertia. Or if someone running forward, okay, and someone put his leg for this student will fall over. Why? Because he still have enough energy. The lower part of his body speed equal to 0 when the student put his leg here, so he is fall over. And the same thing when you are sit in the car, you put the seat belt. Why? To prevent yourself from jumping outside the car when you press on the brakes. So this is the inertia. And the inertia depend on the mass. As the mass increase, the inertia increase. Now, Newton's second law, it is a mathematical law. It is the famous law which is said F equals ma. But now we have to be careful of this force, which is the resultant force, the total force, okay? So the acceleration is directly proportional to the applied resultant force acting on the object. F equals ma. Now we have two equations. Stationary object stays stationary, and moving object in constant speed and same direction stays moving unless a force changing its direction. Newton's second law, resultant force equals mass times acceleration. Newton's first law is a special case of Newton's second law. Why? Because when acceleration equals 0, the resultant force equals 0. So the object moves by constant speed. So we back to Newton's first law. So Newton's first law is a special case of Newton's second law. Okay. What is the meaning of a Newton? When a Newton is defined as the force which will give 1 kilogram of mass an acceleration of 1 meters per second squared in the direction of the force. The third law of Newton is for each action there is an equal and opposite reaction equal in magnitude and opposite in direction. Or, whenever one body exerts a force on another, the second body exerts an equal and opposite force on the first. Both forces have to be same nature. If you have a positive charge and another positive charge, so charge 1 will act by a force on the charge 2, charge 2 will act by a force on charge 1. This force is electrical force, so the force have to be of the same type. These forces acting on different objects, not on the same object, okay, and acting on the same line, okay, not the one force up and the other down, no, both forces acting on the same line. Okay, we have many type of forces. We have to remember that we have push, if you are pushing the object, we have pull, okay, we have friction, we have air resistance, we have a force from the engine. If we have object like this, a ball and a rope, we have tension here, we have weight here. So we have many types of forces. We have an upthrust force if we have object here in water, so we have weight and we have upthrust. The upthrust force is coming from the difference in pressure between the top and the bottom part of the object. Again, I want to talk about the weight. If we have object on a floor, this is the weight. If the object on an incline, this is the weight, okay? So the weight all the time perpendicular to the ground, okay? We have another force which is normal reaction. Normal reaction acting in opposite direction to the surface. It is perpendicular to surface, not in opposite direction to weight, okay? Here, this is the normal reaction, okay? So the normal reaction perpendicular to the surface. If we have a wall and we have a ball and a rope, we have here tension, we have here weight, and we have here the normal reaction. So you have to remember what the type of force you are talking about. If we have a mass of 1.5 kilogram and the object accelerated by acceleration of 2.2 meters per second, you can calculate the acceleration using F equals ma. Or maybe the question give you the initial, final speeds and the time. So you can calculate the acceleration and multiply it by the mass to find the value. Now, let's start talking about momentum. We have moment and momentum. Moment is the motion clock and anti-clockwise. Momentum, it is the force or the amount of energy in the object. The momentum of a particle is defined as the product of the mass and velocity. Momentum P equals mass multiplied by speed. So as the object have a higher mass or a higher speed, so the object have a higher momentum or a linear momentum. The unit of momentum is kilogram meters per second. Depending on the momentum, you can understand how the object treat with the other object if it hits the other wall or whatever. Now, F equals ma, this is Newton's second law, and the acceleration is the change in velocity per unit time. This is force. Now, if we multiply both sides by time, so we have mass multiplied by change in velocity, which is the change in momentum. It's equal to the force multiplied by time. This time is the time of contact between object 1 and object 2, maybe a wall or another ball. okay, which is equal to impulse. So the impulse equals force multiplied by time, or change in the momentum, okay? So we can use Newton's second law, F equals ma, to define it. Instead of equals ma, I can say that F equals change in momentum per unit time. So force, it is the rate of change of momentum. From now on, the better way to define the force, it is the rate of change of momentum. Now we have the resultant force acting on the body is proportional to rate of change of momentum. This is another way to define Newton's second law. I talked about weight before a while, and the weight, as you know, it is mass multiplied by acceleration of a free fall, and acceleration of a free fall is 9.81 on the earth. Normal contact, this is normal contact, it's perpendicular to the surface. Here we have no normal contact because the object is not put on a surface or something like this. Here we have no normal contact, we have weight and we have air resistance acting on the object. I can draw something which is called a free body diagram. If I have a ball moving downward, or an object or skydiver, this is the weight and this is the air resistance. This is the free body diagram. Now, sometimes we have many forces like this. We have, this is an object and this is the force. This force have an angle of 20 degrees about the x-axis. We have weight and normal, okay? Now, the weight is not equal to the normal because of the presence of this force. This force have two components, one component on the x-axis and the other on the y-axis. So normal plus vertical component of the force, it's equal to the weight. But if we have no other force like this, so normal equal weight. Let's try to solve this question. A box of mass 5 kg is pulled along horizontal floor by a force of 25 Newton applied at an angle of 20 to the horizontal, figure 4.9. Calculate the acceleration of the box. Resultant force equals mass multiplied by acceleration. The force acting on the object is 25 cosine 20, because I'll take this force, which is the horizontal, it's equal to the mass, which is 5 multiplied by acceleration. In this way you can find the value of the force if there is no friction. But here we have another force, which is a frictional force. So I have take this minus friction equals 5a. Okay, so 25 cosine 20 minus friction, which is 20, equals 5a. Now, principle of conservation of momentum. If we have an object moving forward, we have mass speed, so the momentum is mass speed. If this object interact with other object moving on the other direction, or maybe it's stationary, this is momentum number 2. Okay? Now, what happened is, this is object 1, this is object 2. This is before collision, okay? This is speed 1 and this is speed 2. This is the object 1 after collision and this is the object 2 after collision. After collision, maybe two objects move to the right, or maybe two objects move to the left, or one of these objects stopped and the other continue to move in the same motion. Okay? In all collisions, you have to remember that the summation of momentum before collision have to be equal to the summation of momentum after collision. Okay? This means that m1v1 plus m2v2 have to be equal mass 1 times the speed of object 1 after collision. We put this here, plus m2v2. Let's erase this. Okay, plus m2 v2 after collision. This is a must, okay? The total momentum before have to be the total momentum after collision. Another thing, if the object moving to the right, we give the speed a positive sign. And if the object moves to the left side, we give the speed a negative sign, okay? So this is the positive direction, and this is the negative direction. You can take the opposite thing, that the left side is positive and the right side is the negative. It's the same, but it's better to remember this and not change it at all, okay? So the total or resultant momentum before equal resultant momentum after. Okay, we have many types of collisions. We have elastic collisions and non-elastic collisions. Elastic collisions, if the objects hit each other and they back and not stick together. If the objects after collision sticks together and moves together, this is a non-elastic collision, okay? If the collision elastic or non-elastic, total momentum before equal total momentum after, okay? But the kinetic energy before equal the total kinetic energy after only if the collision is elastic. If the collision non-elastic, this is not right. So here we have two objects. This is before collision and this is after collision. These objects moves towards each other, and when they collide, each of one change its direction. Let's take an example in momentum. This is object 1, 2 kilogram, moving to the right by 3 meters per second. And this is object 1 kilogram, moves to the left by a speed of 2 meters per second. After collision, the second object stays moving to the right by 1 meters per second. What happened to object number 1? Okay? Now, m1v1 plus m2v2 equals m2v2 after collision plus m1v1 after collision. The first mass is 2, its speed is 3 to the right, so it's positive, plus the second object is 1, its speed is 2 with a negative sign, okay? So we have 6 minus 2, which is equal to 4. On the other side, we have the mass 2. It is 1, and its speed unknown, and mass number 1, which is 2 kilogram, and its speed is 1 to the right, so it is positive. So here we have V2 plus 2, okay? If we take this 2 to the other side, we have 4 minus 2 equals V2. So the speed of the second object is 2 meters per second, and it is positive, so this object will move to the right. Okay. In this way, we calculate the momentum before and after. We can calculate the kinetic energy, by the way. Let's try to find the kinetic energy before and after. Here, the speed is 2 meters per second. The kinetic energy before is half mv1 squared plus half mv2 squared. Okay, now we have half mv squared plus half mv squared. This is 9 plus 4 over 2, which is 2. We have 11 joules before collision. After collision, we have half multiplied by 2 by 1 squared, which is 1, plus half multiplied by mass, which is 1, v squared, which is 4. 4 over 2, it is 2. So on the other side, we have 3 joules. So it is not elastic collision if the kinetic energy before not equal the kinetic energy after. Momentum and impulse, we talk about momentum and impulse. We said that F equals delta P over delta T, or F multiplied by delta T equals delta P. Impulse of force is equal to the change in momentum. If the collision is elastic, the kinetic energy before collision is equal to the kinetic energy after collision. Collisions in which the total kinetic energy is not the same before and after are called inelastic. Now, if I have object 1 moving here and the other object may be stationary, after collision, since they are not elastic, maybe they stick together and moving together. Okay. Now, let's take another example of two objects which collide together and stick together. This is object number 1, which is 2 kilogram, moving to the right with a speed 2 meters per second. Here we have another object, 1 kilogram, and this object stationary, so its speed equals 0. Okay, after collision, if they stick together, they may move together with one speed. Let's calculate its speed. So, m1v1 plus m2v2 before collision have to be equal the total masses, which is m1 multiplied by m2 multiplied by the speed of these objects, because it's the same. Here we have 2 multiplied by 2 plus 1 multiplied by 0, because its speed is 0, it's stationary. It's equal to the total mass, which is 3 multiplied by the new speed. This is 0. 4 equals 3v prime. Divide both sides by 3, so you can find the value of the speed after collision. Now, if object 1 collide with object 2 and after collision, each object moves in a different direction, like this. We have to take the component of each speed. This is speed to x and speed to y. And here we have speed 1 y and speed 1 x. Okay? And we have to use the relation summation of momentum on x-axis before collision يساوي summation of x-axis after collision, and summation of momentum on the y-axis before collision equals summation of momentum on y collision after collision. Okay, you can see here we have no momentum on the y-axis before collision, so 0 equal m1 v1 after collision in y-axis plus m2 multiplied by v2 after collision on the y-axis. This is a nice idea. Okay, please solve this question from your book and we will talk about it later. That's all in this chapter. Hope you are enjoy studying this chapter. Assalamu alaikum wa rahmatullahi wa barakatuh.